Hello and welcome to the Nevada Historical Society. My name is Sherry and I am the curator of manuscripts here at the Nevada Historical Society. Did you know we're the oldest museum here in the state, going back to 1904? We've moved around a few times, and our latest location since 1968 is on the UNR campus across from the Fleischmann Planetarium. If you've ever been to our museum, maybe you've been led by one of our educational docents. They'll give wonderful stories about different parts of Nevada's history. Can you tell me what one of your favorite artifacts that you saw while on your trip? I know for me, it's our two-headed calf. Of course, our Datsalali and our firearms, but wonderful pieces in our galleries. What we're going to see today is one of our educational docents will be giving you a tour on a specific gallery and a topic of Nevada history. We hope you enjoyed this video and come back to our website to watch the other videos that will be on there. And we hope to see you soon in person.
Today, as part of the Nevada Historical Society's 4th grade history tours, we're going to learn about Nevada's prehistory, the time before people lived here. We're going to learn about some fossils that can be found in Nevada and about the early animals that made those fossils. We're going to learn about how earthquakes and tectonic forces changed the shape of land, and also about how the amount of water and the climate changed over time in Nevada. If you live in Nevada, what are some of the things you see when you go out into the country outside of the city? Maybe some bare soil, some rocks, some grasses, and some sagebrush? This is a desert landscape, and indeed Nevada is a desert. It's very dry. But as hard as it is to imagine, one time long, long ago, all of Nevada was under the ocean, and that's where our story of Nevada's prehistory starts, under the sea. How do we know that Nevada used to be under the sea? It's because of the fossils we find. Fossils are rocks that, when they were forming, had the body of a dead animal or a plant pressed against them, so that an image or outline of the plant or animal is preserved in the rock. We can often tell how old a fossil is by what layer of rock it's preserved in. We call these layers of rocks strata. The newer layers of strata are up on top, and the older layers of strata are further down. These layers are formed over long, long periods of time. Geologists, the scientists who study rocks and the earth, give these long periods of time names. One of the larger divisions of time is called a geologic period. You've probably heard the word Jurassic. That's a geologic period. One very old fossil is that of the trilobite, a marine animal that lived about 542 to 252 million years ago, but is extinct now. Marine means it lived in the ocean. Trilobites swam in the ocean and crawled on the ocean floor, so when we find trilobite fossils, we know that the area was covered by the ocean long ago. Trilobite fossils have been found in the southeast portion of Nevada near the town of Caliente. So trilobites were definitely living in the Nevada seas. Trilobites first appeared in the Cambrian geological period before there were even dinosaurs. What do these models of trilobites remind you of? They look a bit like crawdads or lobsters, but they're more closely related to spiders or scorpions. When you look at most fossils of trilobites, you'll see that the little antenna features and the little legs have gotten broken off while the fossil is being formed. We don't really know what color trilobites were, but the artists who make these models will often give them the colors of an animal with a similar lifestyle, like a lobster or a shrimp, and that's a good guess. Now we move forward in time to a geological period called the Triassic. We're now in the age of the dinosaurs, and this brings us to our second fossil, The ammonite. This is another marine animal. What does it remind you of? Maybe a seashell? We don't have ammonites anymore. They went extinct at the same time the dinosaurs went extinct. But there were lots of them in the sea at one time, all different sizes. The biggest ones were as big as a car tire. When you look at this model of an ammonite, what does it remind you of? Maybe a squid? Ammonites were related to squids, but not really closely. And now we come to one of my favorite fossils. Do you recognize this guy? Try imagining him much bigger, as big as a school bus. Now you've probably recognized our state fossil by now, the ichthyosaur. Like the ammonites, ichthyosaurs lived in the Triassic. The name comes from the Greek language meaning fish lizard, but this wasn't a fish, definitely not a fish, and it's not a lizard. It was a swimming dinosaur, and it breathed air. The first ichthyosaur was discovered by 12-year-old Mary Anning in 1811 in England. Mary's fossil was only about 6 feet long, but in Nevada we have some really big ichthyosaur fossils. Another interesting thing about these big Nevada ichthyosaurs is that the juvenile ones, the ones that were still growing up, had teeth, but the adults didn't. So the ichthyosaurs would have baby teeth that they'd eventually lose, but they wouldn't get any permanent teeth. What did ichthyosaurs eat then? Well, anything they could catch, like ammonites. How could an ichthyosaur with no teeth catch an ammonite? Well, scientists think that the ichthyosaur would swim up behind the ammonite and then open his mouth really fast, creating a suction like a vacuum, which would pull the ammonite into his mouth, and then he'd swallow it whole in a big gulp. Some modern whales and some sea turtles eat that way, which is what gave the scientists the idea. How long is a long time? Let's think about geological time for a minute. Dinosaurs were on the Earth 165 million years. And before that, the trilobites were on the Earth for about 270 million years. And those are big numbers. But what do they really mean? To help you understand, I have a demonstration using some string. And in this demonstration, I'm going to use 1 centimeter of string to represent a million years. And a centimeter is about as long as my pinky is wide. So that's a million years. Here's another million years. Here's another million years, and so on. So I've got a string that's 165 centimeters long, representing 165 million years, and that's the amount of time the dinosaurs were on the Earth. Let's see how long the string is. It's a pretty long string. Okay, so there's our 165 million years. Now for the trilobites, I've got one that's 270 centimeters long, representing 270 million years. Let's see how long it is. This is a longer string, almost twice as long. Now I think people should be in this demonstration too, don't you? So modern humans, people like us, have been on the Earth for 200,000 to 300,000 years. So that's less than a million years, so it's going to take less than a centimeter of string, right? So here's our string. There you go. That's us. That's how long we've been on the Earth compared to the dinosaurs and the trilobites. To learn more about how the landscapes changed in Nevada over time, we move forward to the Tertiary period. So over time, tectonic activity has created changes in the surface of Nevada. What does tectonic mean? Well, tectonic plates are large areas of the Earth's surface, like skin on an orange, but in pieces. Now these pieces shift sometimes, and the shifting can cause tugging and pulling on the plate next to it. This pulling can also cause some stretching of the Earth's crust on that adjacent plate, and that's what's happening in Nevada. The Pacific plate has some of California and the ocean on it, is moving north, and that causes tugging on the North American plate where Nevada is. And that tugging is causing stretching, which forms the rows of mountains in Nevada. This is Nevada's famous basin and range topography. It's said that when you look at a map of Nevada, it looks like there's an army of caterpillars crawling toward Mexico. Does it look that way to you? There's another way to think about how these mountains form. If you have a rug on a floor or a piece of cloth on a table, and you tug on one corner or edge of it, it can cause wrinkles. It's similar to how the mountains were formed by tugging in Nevada. Along the base of our rows of mountains are earthquake faults. Have you ever been in an earthquake? Earthquakes are common in Nevada, especially little ones. When an earthquake happens, the land on either side of an earthquake fault moves in different directions. And in Nevada, that direction is mostly up and down, with the mountainside moving up and the valley side moving down. This is the kind of movement that formed our mountains over millions of years. In December of 1954, two large earthquakes happened in northern Nevada, one near Fairview Peak, not far from the town of Fallon, and one in Dixie Valley, a little farther from the town of Fallon. Sometimes when you look at an earthquake fault, it looks like somebody cut into the side of a mountain, making a bare area. This bare area is called an earthquake fault scarp. The Fairview Peak earthquake caused about 10 miles of fault scarp to form. This scarp makes it easy to see where the earth moved. The Fairview Peak earthquake dropped the valley side of the fault 6.5 to 10 feet in some places. That's a lot of movement for one earthquake. This was a modern earthquake, but it helps you imagine how our basin and range landscape formed. These rows of mountains that we've been talking about are the characteristic topography of an area we call the Great Basin. The Great Basin covers most of Nevada and parts of neighboring states. The word basin has a meaning like bowl. So when we say the Great Basin, we mean something like the giant bowl. And this refers to what happens to water in the form of rain and snow when it lands in the Great Basin. Like pouring water into a bowl, the water doesn't flow out, it stays in the bowl. And this means that the rivers that are inside the Great Basin don't flow to the ocean like rivers outside the Great Basin would. Instead, they end in a lake like the Truckee River ends at Pyramid Lake, or they end in a flat area called a sink, where part of the water sinks into the ground and the rest of it evaporates. The fact that our rivers don't flow to the ocean turns out to have been really important in Nevada history, and you'll learn more about that as you learn more Nevada history. We're now moving forward in time to a geologic period called the Quaternary. The first part of this is an important and interesting epoch called the Pleistocene. The oceans all receded long before the Pleistocene, so when we talk about water in Nevada at this point, we're talking about fresh water, not salt water. And there was indeed a lot more water in Nevada than there is now. During this time in Nevada, there were forests of redwoods and oak trees. And in these forests were marvelous, huge animals that don't live here now. Take a look at this model of a fossil. Any guesses as to what it is? I'll give you a clue. It's a tooth. So of something big, right? How about one of these? By now, I think you've recognized a woolly mammoth. Now, our mammoths were a different kind of mammoth. They weren't as woolly as these. We called them Columbian mammoths. They were taller and not as fuzzy, but they did have the characteristic top knot on their head and the big curving mammoth tusks. During the Pleistocene epoch, Columbian mammoths, camels, and bison lived in Nevada. Mammoth fossils have been found near Elko, Nevada. Down near Las Vegas, scientists have even found fossils of a saber-toothed cat. Near Carson City, the footprints of giant sloths have been found. These sloths were as much as 8 feet tall. That's as tall as the ceiling in most houses. We have a special name for fossil footprints. We call them trace fossils because they're made from the activities of a living animal and not the body of a dead one. Speaking of fossil footprints, what's this? Do you recognize this footprint? You may not recognize this one. This is of a camel, a kind that's extinct now. Now, interestingly, looking at the fossil record of this kind of extinct camel, we can't tell whether the camel had 1 hump or 2 humps. Why do you think that is? Think about how a fossil gets formed. What generally gets saved and what gets preserved in the fossil record? Usually just the bones, right? So that's why we can't tell for sure whether the camel had 1 hump or 2 humps, because the soft tissues aren't preserved in the fossil record. During the Pleistocene, we had a series of ice ages. The freezing and thawing left a lot of water behind in Nevada, so we can think of the Pleistocene as Nevada's lake period. The ice ages caused some really big lakes to form. One of these, ancient Lake Lahontan, covered much of northwestern Nevada, and fingers of it reached into southeast Oregon and northeast California. Ancient Lake Lahontan included modern Pyramid Lake, which was about 900 feet deep then, much deeper than it is now. While Lahontan's water was deep, 13,000 to 23,000 years ago, the dramatic tufa formations that you see at Pyramid Lake, including the pyramid itself, formed under the waters of Lake Lahontan. Tufa is a kind of rock, calcium carbonate, and it only forms underwater. Can you imagine how different these pictures would look if water were entirely covering the tufa? In some of these images, you can see marks where the water was higher at one point. Gradual climate change at the end of the Pleistocene age and the rising of the Sierra Nevada mountain range, which blocked moist air coming in from the ocean, saw to the gradual drying up of ancient Lake Lahontan. As the water levels dropped, the waves carved marks on the shorelines. As you drive through some areas in northwestern Nevada, you can see marks of the successive shorelines. They look like parallel lines, or like bathtub rings, or sometimes like stair steps. As Nevada became drier, more than 3/4 of the large Ice Age mammals became extinct. But even as Nevada became drier, it wasn't as dry as it is now. Some large remnants of Lake Lahontan's still remained. We have evidence that people came to live along the shores of these remaining lakes. We call these people the Paleo-Indians because we don't know very much about them. They didn't leave very much behind, but they did leave behind dramatic rock art, or petroglyphs. The very oldest petroglyphs that have been found so far could be as old as 10,000 or even 14,000 years old. And these oldest petroglyphs were found right here in Nevada at a place called Winnemucca Lake. With the arrival of people in Nevada, a whole new story begins, the story of Nevadans.